Hello everyone. For this video I will be showing for my final project how I am going to use JFree Chart to create a data logging chart using an Arduino in Java. So I got this idea from a YouTuber called upgrdman, and he posted a video in 2015 of how he used an Arduino sensor data through a serial port to log data into JFree Chart. For those of you who do not know what Arduino is, it is a basic, simple microcontroller which you can flash a program written in C, and by using different outputs on the microcontroller you can read data, write data, both digital and analog, and do things like make a weather station or turn lights on and off and so forth. For this project I will be using the Arduino Nano, which is a slightly smaller version of the most popular Arduino, the Uno. Here's the setup for my Arduino. I have the Arduino Nano right here connected to my computer via the dock, and through these cables is the sensor I'm using, which is called an HDC 1080. The sensor is made by Texas Instruments, and it records both temperature data and humidity data, relative humidity. And I chose this one because it is very accurate compared to the normal one that most Arduinos use, which is the DHT11. This can be off by 3 or 4 degrees Celsius, so I wanted a much more accurate reading over a long term, many hours of graphing, so I chose this one. So on the Arduino side, this is the code for the Arduino, which is written in C++ as far as I understand. And the sensor comes with a library already to go, so we're just including these libraries so that we can use the output. So in the setup, we begin the baud rate, which basically is just part of the clock output, and then we begin, because the HDC 1080 is an I2C, we have to define what its address is, and then within the loop all this code does is print a line on the serial output for the temperature, and then it prints for the humidity, and then it delays for 1 second. Originally my plan was to use an application called CoolTerm, which would take the serial data from the Arduino when it was plugged into my computer and then turn that into a text file, and then I would use that text file with Python to read it, or read it as either a text file or a CSV file, extract the data into an array, and then build a graph with that using a library called matplotlib, which is a very popular library for data analysis. However, I ran into a lot of problems while using this because a lot of the external libraries wouldn't work all the time with matplotlib, and it got very complicated, so much that I had to mess with environmental variables in both Windows and macOS, and it really wasn't worth the time of configuring everything just to get it working. So I decided to leave that option as something I can try in the future. Instead, what I did is I went back to Java, which I know fairly well because I've programmed with Java for years, and I used a library called JFree Chart instead of matplotlib, which isn't as good as matplotlib because not as many professionals use it, but it can still do the job, and I have the bonus of having live data entry instead of having to wait until I'm done entering the data and then compiling it into a graph, which is the bonus of using JFree Chart and then also using a serial input at the same time. So my project consists of a main class right here, although there are smaller classes within it that do different functions, and With that, there are also one or two methods and a thread just for reading the serial data. Apart from that, there are 3 external libraries that have to be used over here. There's a JCommon, JFree Chart, which is for the module, and then there's also one for the serial COM port so that it can connect and read data out of the USB port from the Arduino. These all have to be included when running the main, which you add them by going to Project Structure and then going down to Modules, into Dependencies, and then you add right here, and then you find where the files are and you just add them into here. And then whenever you go to run it or compile a jar file and export it, they will be included. Otherwise, it just doesn't run and it doesn't know how to figure out where the serial port is or the graphing functions, because all of the commands are stored within the external libraries when they're referenced. As you can see, we're referencing a lot of them right here and importing them. We're also using java.swing, which is the basic Java GUI. And then we're also using, more importantly, the java.util.scanner. So a lot of the movement that isn't done by the external library we're using scanner. So instead of using scanner when we normally use Java for entering stuff from the keyboard, it's entering stuff from the serial port, and scanner helps with that. Here's our public class called main. We have a lot of static doubles, which will go between, they will stay the same. I'm using a double because a lot of my values have decimal points and integers will not work. This is one thing I changed from upgrdman's code. I needed a double to work so that I could have decimal places of the temperature and the humidity, since my sensor is that accurate. So I changed everything to a double and have 2 sets of that. And these are used as the data points. So there's a current and a last. The current one is the current chunk of data that's being entered, and then there's also an X value, which I will talk about later. So first thing that we do is we add a window called new JFrame, and then we set the title at the top, and we set the default size. You can stretch the size, but this is what it is set to in terms of pixels. And then we have window.setLayout, border layout. This creates certain regions on the window, so I can have a region for the graph and then a region at the top to connect and add buttons and other labels. This is what separates it. And then, of course, there's an exit on close, which you have to have with every Java program or GUI program, so that when you click the X in the corner, it will shut down the program instead of having to shut it down in the IDE up here. Then we have a lot of configuration for our port. We have 2 labels that will be at the top of the GUI. We have a current temperature and a current relative humidity, and these will basically show the current temperature and humidity as the data is coming in. It'll show the last ones values entered. And then most importantly, we have a J button called connect, and this button is quite complicated. I didn't change anything about it, but the text on the button will change, and how it interacts will change depending on if it's connected or not. So one of the elements or borders of the GUI is called the top panel. That is not the graph. This has the button and then the 2 labels on it, and we set the position of it to north, which just means the top of the window. Here's the part to connect the serial port. It uses the library to give the available ports, so there will be a drop-down list with the inside the GUI, and we can select however many ports the port that will show up is whatever, if there is an Arduino plugged in, there will be an available USB port that it will show. So if you have multiple ones plugged in, you can choose between them. This is the part that creates the graph. It's called XY series, which creates a new graph. One thing that's important is that they're called a collection, and you have to have at least one series within the collection. So this line right here, if you only have one data set, one incoming stream of data, and not two separate lines within the graph, this has to be grayed out. Otherwise, it will read improperly. So in this, I have one for the humidity, or the temperature, and then another for the humidity, and this will run in the same graph and display at the same time. And then right here, we're just adding titles, X and Y axis labels to it so that the graph is better interpreted when you view it. And right here, we're just adding it to the GUI, and we're putting the position to center. Right here, we have our action performed when the button is clicked. This is our action listener, event listener. So it will say connect, and then if it'll say connect, and then otherwise it will say disconnect if the port is not enabled. Otherwise, this part allows it, if there's a timeout, if it times out, then it will go into the other statement. For this, we also have to create a thread, because while the program is executing, we also need another separate thread just to read the serial input while the program's doing other things. So this thread is all it's doing is reading the serial data as it comes in continuously. So while scanner has, so we're using the scanner right here, and while the scanner has the next line, which is basically when when more data appears in the scanner, it will record it, and it will call it line, or label it as number. So then we have our series, our temperature series, and we add an X value for the X-axis, and then we have our Y value, which is the actual data, the temperature that's added. And so that the X value will be the time in seconds, X is seconds, and every time a new data set comes in, it will add 1 second because I set it to 1 second intervals. So the X-axis will grow by 1 second every time data is entered. On the same note, it will also enter a new number from the scanner every time. And then it has to repaint the window. Sometimes if you don't put this in here, it won't repaint after a certain number of minutes or so that has to be added. And then down here, it's doing the same thing for the humidity. But at the end of each of them, I have the labels that are set at the top of the GUI, and this has to reset the text for the current temperature so that it always displays the last known temperature. And it does this by taking the string value, and then it parses the string, which is the current temperature, and then it adds it with parses it into the double, so that it has both the current temperature and the label that says if it's the temperature or the humidity. And there has to be also an exception so that if some corrupt input happens, if it's not getting a value or whatever, then it'll print within the terminal corrupt input detected. Without this, you can crash the program pretty easily if you disconnect or have some other problem with the serial port. Otherwise, this helps disconnect if necessary from the serial port, and this clears the data. And finally, you have the window set visible equals true, so you can actually see the window inside. Other than that, let's see how it runs. We'll click Run. And here it is. So up here we have our selection for the serial port. So I have my Arduino plugged into the USB port, and it's showing on COM5, which out of the 6 USB ports I have, it's plugged into USB port 5. So we select that until it's gray or bluish gray, and then we can click Connect. And now we can see our two series, the temperature readings and then the humidity readings down here. And if I put my finger right above the sensor, you can see the water from my hand that's just off-gassing is increasing the humidity and also the temperature a little bit, so it is working. And as you can see down at the x-axis, every 1 second it's indexing that x value so that it's increasing by 1, and this will keep expanding and expanding as long as this runs. As for the y value, with this, because I have two series and they fit together within similar values that they're actually readable on the same chart, I kept them on the same graph just for comparison's sake. I could add one more down here and increase the size of the windows, but looking at both of them at the same time is quite valuable, so I just kept them together since this reads in Celsius and the relative humidity goes between 0 and 100, so I keep them together. Up here you can see the top chart, the north part right here, which has obviously the COM port, the disconnect, which you can click disconnect, and then whenever you want to connect again, it'll pick up right where it left off. Right here we have the label, our first label, called current temperature, and it will update with whatever the current temperature is in the double format. This is in Celsius. And then also it has this another label for current relative humidity, and this is showing the percent humidity. Additionally, I wanted to add that if you want to recreate this, you will need 3 libraries, which are found inside of the video that upgrdman used to run this. I also have an executable jar that will run the program. However, sometimes this does not work without the external libraries because IntelliJ isn't adding them to the jar file, so you might need to run this with IntelliJ IDE and the external libraries added to whatever project is open at the moment when you run it. It will run separately, but it has to be included somewhere on the system, as far as I can understand. Anyway, thank you a lot for watching this, and I hope you have a great day.